Hello and welcome to BioRules video lessons. Today we are going to be talking about enzymes again, but basically about how the environment influences enzymes. So first one, classic one, basic, temperature. How do temperatures influence enzyme? So different temperatures influence proteins. We saw this already. We talk about denaturation, that if you change the temperature, you may change the protein slightly, but you may change it a lot, and then it's denaturate all the stuff. So enzymes are basically proteins, sometimes nucleic acids, and they also suffer with temperature. No hotter or colder temperature change the enzymes the same way that change any other proteins. So let's take a look here on how temperature is going to be affecting enzyme activity. Enzyme activity by here, I'm going to be saying that is the products that have been produced or the substrate that have been consumed. Anyway, you can measure enzyme activity by seeing how much product is there or how much substrate is left there behind. And basically, it's just like any other protein. If we increase the temperature from near zero, we are going to have more reaction because the molecules are going to be bouncing more on each other. So from very low here, what happens is that you start having more molecules bouncing around, and even the enzyme not having the perfect shape, it's going to allow some of the reaction to happen. They are going to be allowing the substrate to fit over there, and you're going to start having more reaction. And basically, hotter, you're going to have more and more. Usually this might be exponential or may be shown as linear. No, it's more like an exponential growth in the beginning because hotter means more molecules bouncing around, so faster, but also means a better shape, a more optimized shape of the enzyme. So usually this grows very, very, very fast until it reaches there near the optimum. And then when you get close to the optimum over here, you have a lot of molecules bouncing and the enzyme is in the perfect shape to be able to make the chemical reaction happen. But above a certain temperature, the optimum, then you have the problem that the enzymes are changing the shape so much that it doesn't act so well anymore, and after a while you also start having denaturation, that it breaks down and stops working at all. Okay, so we have an optimum temperature. In the case of our bodies, usually around 37. We saw this for other proteins. I hope that you know this, you nail it. And the typical shape for temperature is this sugar loaf shape. It's a not so fast growth in the cold part, and then an abrupt drop when it gets to the hot side of this graph, because hot denaturate the enzymes. Okay. We also talk about pH. pH is something that also influences proteins, and if we put over here the pH affecting the enzyme activity, we are going to have the same thing. There will be an optimum over there. The pH where it works better, for example, the enzymes in your mouth, they have an optimum pH around 7. So if you move a little away from that, the enzyme change shape a little bit and it works less, so it's a little bit out of the optimum. But it's returnable. It's reversible. But if you change too much the pH, then the enzyme gets destroyed and then denaturated. So you saw this is the same idea as what you saw for other proteins. Is just like any other protein. So nothing new here. Enzymes are proteins or something that will behave like proteins. So they suffer temperature, they suffer pH the same way that any other protein do. Okay. Now, something that we didn't see about proteins, which is the substrate concentration. If you have no substrate, you're going to have no enzyme reaction, because enzyme activity is the product produced or the substrate consumed. If you have no substrate, can you have any chemical reaction? And if your answer was no, you're right. No substrate, no chemical reaction. So it starts in the origin, it starts there in the bottom. And then, if I start having more substrate, what would be expected? Yeah, if you thought you start having more reaction, or you start having products being made or substrate being consumed, you're right. The more substrate, usually that means more reaction. And it's usually quite linear. The more substrate you have, more reactions you are going to be having happening there. The more substrate, more reaction. Okay, you got the idea. However, can this go on indefinitely? Can this go on forever? More substrate, more reaction, more substrate, more reaction, more substrate, more reaction? No. Okay? When you have so many substrate molecules, there will be a limit on enzyme number to be acting on. There will be a moment that you have so much substrate that you don't have enzymes anymore that will be capable of doing the job. So all the enzymes get occupied, all the active sites get occupied. And then they start they act on their maximum capacity. They are doing all they can. But they cannot go beyond that because they are all working at its maximum. All the active sites get occupied all the time and you reach a plateau. There's still a lot of reactions taking place there, but it doesn't go faster. It reaches a plateau. This is the effect of substrate concentration on enzyme activity. So much substrate, you don't have enough enzymes to be acting upon the substrates that you have over there. Okay? Similarly, what happens if you do the opposite? What happens if you have a lot of substrates, but we change the concentration of the enzymes? So there enzyme activity again, products produced or substrate consumed, and then the question is, are you going to have a chemical reaction if you have no enzyme? So technically you could have, because no enzymes, they speed up chemical reactions, but in case of biology they speed up so much that without enzymes it's as if you don't see any reaction happening at all. So basically in reality, no enzyme, you have no reaction. And what happens if you start putting enzymes? More enzymes, more reaction. Duh! Right? The same thing. Quite linear. The more enzymes you put, more reaction is going to be happening because then you have more active sites to be acting on all those substrates that are around out there. Is this going to go on indefinitely? No. It will also stabilize because there will be a moment that you have so many enzyme molecules that you don't have enough substrate to be acting upon anymore. It's as if now you have a low substrate in relation to how much enzymes you have. You still have a lot of reaction taking place, but it just doesn't get faster. You reach a plateau. So concentration has this typical shape. It starts in the zero or very close to the zero, grows more or less linear, the more enzyme, the more reaction, or the more substrate, the more reaction, until another limiting factor starts kicking in. In this case here, the enzyme concentration is getting so high that the substrate concentration is an issue now. We don't have so much substrate. So there will be enzymes that are going to be unoccupied. They're going to be free. They're going to say, oh, I'm bored. There's nothing for me to do here because I don't have enough substrate anymore. We are way too many. And then you reach a maximum. They don't stop. They just reach a maximum. They are reacting to the maximum of the substrate that's possible to work on there. This effect of enzyme concentration or substrate concentration is this typical graph. Putting everything together, temperature looks like the sugar loaf. No, you have the naturation going there on the right. No, there it is. You don't have the naturation happening on the left on the cold side, but they reduce, they go down. Okay, this is pH. You have an optimum pH over there, and you have the naturation on both extremes. Extreme pH for acid or for alkali is going to be making these reactions to slow down. Okay, there it is, the naturation. Okay, and concentrations, you have this typical curve. The more enzyme you have, more reaction you have until it reaches a plateau. And if you get to that plateau, then no, it can go on indefinitely on that. Remember, it's not stopping, it's just working at its maximum. And again, no denaturation. Too much enzyme do not denaturate the enzymes themselves. The same happens for the substrate concentration. No substrate, no reaction. The more substrate, more reaction, until you don't have enough of something else rather than substrate to be working. So, for example, you might not have enough enzymes to be working on. So all the enzymes that are there will be working at maximum capacity, and they reach a plateau because they are working at maximum. Again, maximum. They don't stop working, they work at its maximum capacity, reaching a limit, reaching a plateau. Okay? These are the typical curves for environmental factors, temperature, pH, and the concentrations. They have this typical curve. Classic, very important for you to understand how these factors work on enzymes or in any protein whatsoever. What I would like you to do now is to run a simulation. Okay, if you go to this website, kscience.co.uk, animations model SWF, you can choose some factors regarding a few enzymes over there. So choose 2 enzymes, 20 substrates, pH 7, don't put inhibitors, don't change anything else, and play it for 20 seconds with different temperatures. So you're going to have 0, 10, 20, 30, 40, 50, 60, 70, and 80. This is going to be our independent variable, and you're going to be running it for 20 seconds. And I can tell you in advance now that probably at 0 degrees Celsius, unless an enzyme got just on the top of the substrate, you're going to end up having 20 substrates and 0 product because it's not going to be reacting. And probably here the same will happen because probably at 80 degrees Celsius the enzyme are not going to be working anymore. But what I want from you is for you to run the simulator, gather the data. If you want to make a very drafty sketch of what the data looks like for you to see a trend, make it in your notebook just for us to discuss. Bring the data. We are going to be discussing this in class, and you can even do other simulators run in class. Okay, so run this down so you see the effect of temperature on enzyme concentration. Then we may do it for pH, maybe then we can do it for enzyme concentration, we can do it for substrate concentration, and so on. Okay, I see you in class. Oh, sorry, do the quiz over here so you can see how well you have understood this. It was fun having you around. See you in class.